Hello dear students, my name is Uddhav Khatri, Department of Mathematics, Indian Academy Pre-University College. Today we are going to discuss a few important things about the most important polynomial, that is quadratic polynomial. First of all, let's understand what's a polynomial. Polynomial contains many terms of the form a0 plus a1x plus a2x square plus and up to an x to the power n. Please remember that even if there are many terms, you have to look at the power of x. The power of x should be whole numbers. Only then this expression will be called a polynomial. Now, what about the degree of the polynomial? The degree of the polynomial is the highest power of x. In the example I gave you just now, the degree of the polynomial will be n because the highest power of x was n. Now let's look at a quadratic polynomial. What's a quadratic polynomial? Quadratic polynomial is of the form ax square plus bx plus c. Here you have to remember that the leading coefficient, that is the coefficient of x square, should not be 0, and the highest power of x is 2. So this is a polynomial called a quadratic polynomial whose degree is 2. What about quadratic equation? The quadratic polynomial, if you equate it to 0, then you will get a quadratic equation. And if you have a quadratic equation, you will have two different values of x which will make that quadratic polynomial 0. And that's why those values of x, we call them roots of the equation, or sometimes they are also called as zeros of the polynomial. So at what values of x the polynomial is going to be 0? That's why we call them zeros of the polynomial. Here it is important to note that we have different kinds of roots. Those are called as nature of roots. So based on the kind of roots we are going to get, whether the roots are going to be imaginary, whether the roots are going to be distinct, or the roots are equal. So we have to solve this quadratic polynomial using factorization method or using the formula method. And the formula to solve the quadratic equation is x equal to minus b plus or minus square root of b square minus 4ac whole divided by 2a. And all of you are familiar with this formula. In this formula you are going to get two values of x. Those are called roots of the quadratic equation. Let's look at what is coming inside the square root sign, that is b square minus 4ac. b square minus 4ac is called as the discriminant of the quadratic equation. So the discriminant represented by delta is b square minus 4ac. We can decide the nature of roots based on the discriminant. If the discriminant is equal to 0, then you are going to get equal roots. If the discriminant is greater than 0, then you are going to get two different roots, and those roots will be real roots. But what if the discriminant is less than 0? If the discriminant is less than 0, you are going to get imaginary roots. What do you mean by imaginary roots? We are dealing with real system, and if you try to plot the quadratic polynomial in xy plane, you will notice that the graph of that quadratic polynomial will not cross the x-axis. And if it is not crossing the x-axis, it means there are no such values of x which will make the polynomial 0. And that's why we are getting imaginary roots. So when you have imaginary roots and when you need to draw the polynomial, you will definitely observe that the graph, which will also be a parabolic graph, it will not cut the x-axis. If the polynomial graph, that is quadratic polynomial graph, is cutting the x-axis, obviously there are real roots. The question is whether the parabolic graph will be upward facing or the downward facing. That also can be understood or can be identified using the coefficients of x square as well as the discriminant. First of all, remember a few cases. Let's look at the discriminant to be 0. If the discriminant is 0, then look at the coefficient of x square. If the coefficient of x square is less than 0, then the graph will be downward facing. And if the discriminant is 0 and a is greater than 0, then the graph will be upward facing. And both these graphs will touch the x-axis. They are going to touch, they are not going to intersect the x-axis. Because we all know that when the discriminant is 0, you are going to get equal roots. So you are sure that the graph of quadratic polynomial will not cut the x-axis at 2 points, but it will just touch the x-axis. That is, x-axis will be tangent to both the graphs. What are both the graphs? When the leading coefficient, that is x square, the coefficient of x square, which is a, there are two cases, a less than 0, a greater than 0. If a is less than 0, graph will be downward facing, and if a is greater than 0, graph will be upward facing, making sure that d is 0. This is the first case. What if d is greater than 0? Now when d is greater than 0, again we have two cases, the leading coefficient less than 0, the leading coefficient greater than 0. Less than 0, a is less than 0, graph will be downward facing, and a is greater than 0, graph will be upward facing. And both these graphs will cut the x-axis at two different points. Obviously, because if d is greater than 0, you are going to get two real and distinct roots or zeros of the polynomial. This is the second case. What about the third one? Now the third one, d is less than 0. Again in d less than 0, you have two cases. One, the leading coefficient less than 0, the leading coefficient greater than 0. If the leading coefficient a is less than 0, graph will be downward facing, and if the leading coefficient a is greater than 0, graph will be upward facing, and both these graphs will not touch the x-axis. Obviously, because d, which is a discriminant, is less than 0, means you are going to get the imaginary roots. I hope you understood all the 6 kinds of graphs for the quadratic polynomial, and it helps us understand quadratic equations and polynomial well. And I hope my video today helped you in some way. Thank you.